Hi everybody, it's Miss Austin. We're jumping into lesson 16. We're doing activity 16.1 in your book. Hopefully you watched the first video, which was a quick review of completing the square, which is a strategy for solving quadratics. Today they expect you to solve quadratics using completing the square and the quadratic formula. So this first activity kind of directly correlates to the PowerPoint that I was just sharing. It says the expression x squared plus 8x plus 16 is equivalent to x plus 4 squared. If I made a box of this real quick, watch. My x squared goes here. If I cut the 8 in half, I get 4x and 4x. X, 4, 4 times 4 is 16. Because that's a 16 and everything works out perfectly, instead of writing this quadratic like that, I can write it as x plus 4 times x plus 4. But since it's the same thing twice, I can just write it as x plus 4 squared, which is going to be helpful when we solve quadratics. So down here, they're asking us which expressions here are examples of perfect squares. So we can kind of look, we could try to make the box and see if it all fits together. We could also just look at this middle term, right? I'm probably just going to make the box so you can see the practice again. If I put x squared here and I cut this in half, I get 5x and 5x. So that's x, 5, 5. 5 times 5 is 25. Yep. This one can be rewritten as x plus 5 squared. So this is one that works. Okay, what about this one? We can use this box already because it's exactly the same, except it's got a 29 here. We already know if we cut 10 in half, we're getting 5 and 5. And 5 times 5 is 25, not 29. This problem cannot be written as the same thing times itself because there's no whole number times itself that makes 29. This one doesn't work. Okay, let's try this one. And you don't have to do the box. Again, you can just, here's the other quick way. Cut that number in half, 5, and square it, 25. Yes, this one can be rewritten as x plus 5 times x plus 5. So this would be x squared. Cut that in half, you get -3, -3. That'd be x, -3, -3, which would make what? This number needs to be a 9 in order for this to be rewritten as the same thing twice. That's not a 9, that wouldn't work. But then look here, oh, this one is a 9. This problem can be rewritten like that. You want to be able to start noticing problems that are already set up like that. They make solving quadratics a lot quicker. Again, if you need to refer back to the first video of how we got this and the strategy behind it, go ahead and rewatch that again. Thanks for watching. The next video is going to cover 16.2.